Hey everybody, Mr. Covey here, and this is 9-9, and we're going to talk about trigonometry. So there are three trigonometric relationships: sine, cosine, and tangent, and they are abbreviated sin, cos, tan, and what they are is just ratios of sides, and they're with respect to an angle. For instance, if I say the sine of angle R, if I go over here to angle R, since I am doing the sine, I look at the leg opposite, which in this case would be side R, and I look at the hypotenuse, which would be T, and I form a ratio. So the sine of angle R is side R over side T. If I was talking about the cosine of angle R, I'm still looking at angle R, that ratio is the adjacent side over the hypotenuse. So my adjacent side would be S. Again, remember that adjacent means next to. So it's the side, the leg next to angle R divided by the hypotenuse. So it's S divided by T. And if I was talking about the tangent of angle R, again, I'm talking about starting at this angle R, the tangent is the opposite leg over the adjacent leg. The opposite leg in this case would be ST, which we call R, and the adjacent leg would be S. So the ratio for the tangent of angle R would be side R divided by side S. One other thing to note about how this triangle is labeled is that the sides are labeled with the same letter as the angle they are across from. For instance, since this is angle T, we labeled this side lowercase t. That's going to be a convention that we use a lot. So it's good to know in your geometry life. And finally, if you want a quick way to remember what sine, cosine, and tangent, what ratios they are, there is the acronym SOHCAHTOA, which tells you that if you are dealing with the sine of an angle, you look at the opposite leg divided by the hypotenuse. If you are trying to find the cosine of an angle, you look at the adjacent side divided by the hypotenuse. And if you are talking about the tangent of an angle, that means the opposite leg or opposite side divided by the adjacent leg. Okay, so if you remember SOHCAHTOA, remembering which one's which is a lot easier. Okay, so if I wanted to know the sine of angle D, it is asking me for the side ratio that represents the sine of angle D. Here's angle D. Sine is opposite over hypotenuse. Opposite is 5. It's my opposite. That's my hypotenuse. That's my adjacent. So sine would be 5 over 13 for angle D. If I wanted the cosine of angle D, remembering SOHCAHTOA, cosine is adjacent divided by hypotenuse, so it would be 12 over 13. And the tangent of angle D would be opposite divided by adjacent, so it would be 5 over 12. I want you to go ahead, pause the video, do these 6 problems, and then come back and check your answers. Okay, those are your answers there. A couple things I want to make sure we're clear about. You can't just say, I'm talking about this triangle, what's the tangent of it? If you ask for the tangent, you need to say what angle you're taking the tangent with respect to, or the tangent of what angle, because it changes what's opposite and what's adjacent. So if you're talking about angle L, 30 is the opposite side. If you're talking about angle M, 16 is the opposite side. One other thing, note that the sine of angle M is the same as the cosine of angle L. And we see that kind of thing over here too. The cosine of angle Z is the same as the sine of angle X. Seems odd. Anyway, we'll talk more about that in class. Here, we're just trying to say which trig function they are talking about, sine, cosine, or tangent. So if you look at angle G, and we're talking about 9 over 41, that is our opposite over our hypotenuse. So 9 over 41 would be the sine of angle G. If we're talking about angle H, 40 over 9 would be our opposite over our adjacent, which would be tangent of angle H. Talking about angle H, 40 over 41, that'd be the opposite over the hypotenuse. That would be the sine of angle H. And if we're talking about angle H and we want 9 over 41, that's our adjacent over our hypotenuse, so that would be the cosine of angle H. When we use trigonometry, our problems are going to end up looking like this, so we want to make sure that you can solve for missing variables in problems like this. So here, if we want to find angle A, we want to find side A, to get rid of the 15, we multiply both sides by 15. Go to your calculator, type 15 sine of 20, and that would give us A. One thing to check for sure is that your calculator is in the right mode. So if you grab your calculator, hit the mode button, go down. It should be in degree mode because we're talking about angles in terms of degrees, not radians. Something else. Make sure you're in degree mode, second quit, and then your trig functions are right here. So I'd do 15 times sine 20. A would be 5.13. Go ahead, pause the video, solve the rest of these, and come back to check your answers, please. Okay, go ahead and check your answers there, please. Okay, now on to the good stuff. Why do we care about trigonometry? Why do we have it? It's so we can find the missing side lengths in right triangles. So if you look at this first problem, let's do it two ways. So first, you can recognize that as a 30, 60, 90 triangle using what we've been doing so far. That A is going to be 6 root 3. I want to show you a different way to do it, though, and that would be to use trigonometry. So we have the 60-degree angle. That is our opposite side. The 12 is our hypotenuse. Since we want to find the opposite and we know the hypotenuse, thinking back to our SOHCAHTOA, we are going to use sine. So our sine of our 60-degree angle is going to equal our opposite over our hypotenuse. Solve that. You get 12 times sine of 60 equals A, and you get A is 10.4. You type that in your calculator. I know what you're saying. Those answers look different. If you type 6 root 3 in your calculator, you'll get right around 10.4. Those are just two different ways to do it. Let's do that same thing for this one. This is a 45, 45, 90 triangle. I know C is going to be 8 root 2 because it's a special right triangle. But let's use trigonometry. So if I know this 45-degree angle, that 8 is my adjacent side. That is my hypotenuse. I know my adjacent. I want to know my hypotenuse. I'm going to be using cosine. So cosine of 45 equals adjacent over hypotenuse. Cross multiply, solve that. So I'd cross multiply to get C times cosine of 45 equals 8. Divide both sides by cosine of 45. I'd get C equals 11.3. Which again, if you type 8 root 2 into your calculator, it'll be right around 11.3. I know what you're thinking. Why do we need trigonometry if we can just use our special right triangle shortcuts? It's because not all triangles are special. So this triangle right here, not special. And in that case, the only way to find that missing side is to use trigonometry. So we know our opposite. We want to find our hypotenuse. We are going to use sine. So sine of 15 equals 25 over d. Cross multiply, solve that. You're going to get d is 96.6. And go ahead and pause, do that last one, come back, check your answer. Again, that last one is not a special right triangle, so you need to use trigonometry. You should have used tangent, and you should have gotten E is 8.5. Okay. Last couple problems here. It says a flagpole is held upright by 30 meter long wires to the ground. Here's that wire, 30 meters long. If it makes an angle of 25 degrees at the ground, how tall is the flagpole? They are asking us for this length. So let's throw down a variable. We're assuming the flagpole is upright. Well, it tells us it's upright, so it's going to be a right angle. If we're trying to find our opposite and we know our hypotenuse, we should be using sine. So sine of 25 will equal x over 30. Solve that, and we get that the flagpole is 12.7 meters tall. Last question here. It gives us this triangle, and it asks us to find the cosine of angle C. Alright, well, cosine is adjacent over hypotenuse. In order for us to talk about adjacent hypotenuse, we must be talking about a right triangle. If we drop that altitude straight down, all of a sudden angle C is part of a right triangle. Since it's an isosceles triangle, that altitude divides the base in half, meaning that side is going to be 5, and the other leg, special right triangle, 5, 12, 13. So it's asking us for the cosine of angle C. It's going to be adjacent, which is 5, over hypotenuse, which is 13. And that concludes 9.9.